Hi everybody. I want to share some notes with you about midpoints and angle bisectors. I'm going to do it by using this page, a first look at midpoints and angle bisectors. It begins with not a definition but a description. Sketch a segment PQ with midpoint M. I'll do just that. Segment PQ with a midpoint M. I'm thinking to myself, if that's a midpoint, then this segment would be congruent to this segment. Those would be equal in measure. And that's that would be a good way to note that. Make those kinds of marks. 2 slashes on this one and 2 slashes on that one. There's a conditional statement here. If M is the midpoint of PQ, then, and apparently there's a couple things I must know to be true. The first one, and an obvious one, would be that PM is congruent, therefore equal in measure with MQ. I wrote QM, but that'll be just as good. There is another thought. Consider this. Isn't it true that PM, the length from P to M, is equal to 1/2 the length from P to Q? You might notice here I put segment markers on top saying that these are congruent. But here I'm talking about their measures, and I would not put a segment marker on top. I'm just saying that the measure of PM is equal to 1/2 the measure of PQ. That this length is half of the full length. That makes sense. Further, now we're going to look at an angle bisector. Sketch an angle ABC with an angle bisector BZ. I'll do that on the right hand side. Something like this. I'm going to sketch an angle ABC. Might pretty it up with some rays there. And I declare that it has an angle bisector BZ. I declare that to be the angle bisector. And I'm thinking to myself, well, that would mean if that's an angle bisector, that those two things should be congruent. That's really by the definition of an angle bisector. If BZ bisects angle ABC, then I know two things, very similar to these. You might pause the video and write them yourself before I do. I would say this. Angle ABZ is congruent with angle ZBC. That must be true if we say that BZ is an angle bisector, and we're under that assumption. And there's another one, very similar to this idea. I would say that the measure, because we use that little m for measure, of angle ABZ is equal to 1/2 the measure of angle ABC. Those two things are important. Lots of ways you could think about this one. I might have also said that this angle is 1/2 of the full. It would have been true. When it says that they're congruent, you would know that that means that the measure of angle ABZ is equal to the measure of angle ZBC. That's what it means to be congruent, that they are equal in measure. Now we're going to make some sketches and solve some equations. Sketch a segment AB with midpoint M. And when I ask you to do that, that's exactly what you should do. And show it to me when you turn in your work. Sketch a segment AB with a midpoint at M. It says that AM is 3x minus 2. And AB, recognizing that AB is the full length all the way across there, is 7x minus 10. I think you ought to pause the video and write an equation. I'm going to write the equation right now, though. It makes sense to me that 3x minus 2 here would be as big as that 3x minus 2 there. truth is that this is equal to 1/2 of that. Or I think a simpler thing for me to do, I could say 2 times 3x minus 2. 2 of these segments would add up to the full length AB. 2 times 3x minus 2 would be equal to 7x minus 10. That's the equation that I can solve. I'll do it now. I'll multiply through those parentheses, and that would give me 6x minus 4 equals 7x minus 10. I can subtract 6x from both sides, and that would leave a negative 4 here is equal to 1x minus 10. Add 10 to both sides, and a negative 4 plus 10 will be a positive 6 is equal to x. I'm considering that x must be equal to 6. I'm going to find those couple of lengths. Give the length of each segment. I'll do that here. AM. Since x is equal to 6, 3 times 6 is 18 minus 2, it'd have to be 16. And then AB. 7 times 6 is 42, minus 10 would be 32. I'm happy with that, because I expected AB to be 1/2 of I expected AM to be 1/2 of AB, and it is. And I'll put a box around my answer, make it obvious, and go on to the next question. Here it tells me that segment P, show segment PR with midpoint Q. So on the right-hand side of the paper, I'll do just that. A segment PR with midpoint at Q. Tells me that PQ is x plus 7. In QR, this other small segment is 3x minus 7. I got to come up with some relationship between those two so I can find the value of x. Pause the video and do it yourself, and then come back and check me. What I know to be sure is it's true that PQ is equal in measure to QR. So in the place of PQ, I'll just say x plus 7 is the same as 3x minus 7. And I'll work on solving that. I'll subtract 1x from both sides. When I do that, I'll have just 7 is equal to 2x minus 7. Add a positive 7 to both sides, and then I'd have 14 equal to 2x. So now I'm considering dividing both sides by 2, that x is equal to 7. I've got to go find the lengths of those couple of segments. PQ, when we don't put a segment marker on it, we're talking about the length of the thing. It says PQ, since x is equal to 7, PQ would be 7 plus 7, that's 14. And then QR. QR was 3 times 7, there's 21, minus 7, also 14. If somebody asked me about it, I'd tell them that PR must have been 14 plus 14, therefore 28. And I know all the lengths that I got to know. Put a box around that one and go racing to the next question. This is a little bit different. I'm going to show an angle bisector here, an angle with a bisector. I'll show angle PSR. Just some arbitrary angle. I don't really know how big to make it. I'll just show an angle. I'll call that angle PSR. And it says with bisector SQ. So I'm going to show a ray that looks like it cuts it into 2 equal parts. And call that ray SQ. Got to read these things a little carefully. Angle, the measure of angle PSQ is 3x plus 5. PSQ, that's this angle. 3x plus 5. And the measure of angle QSR, here's QSR, that's the other small angle, is 5x minus 9. I should recognize that those are equal in measure. So the equation will be 3x plus 5 must be equal to 5x minus 9. Solve that before I do, and let's see if we can agree. I'll subtract 3x from both sides. I got 5 equals 2x minus 9. Add 9 to both sides of that equation, and it makes me convinced that 14 is equal to 2x. Divide both sides by 2, and x is 7 again. Now let's check the measures of those angles. The measure of angle PSQ. See you guys, 3 times 7 is 21 plus 5 would be 26 degrees. And the measure of angle QSR, if x is truly 7, then 5 times 7 is 35, minus 9, 26 again. Give the measure of each angle, and I did give the measure of those two angles, but it might be clever of me to say that the measure of the full angle, that would be angle PSR. That must be 26 plus 26, must be 52 degrees there. And nobody could fault me with that. I'm sure that that would be an accurate showing. We got one more thing for me to show you now. Show BD between BA and BC. Okay, I'll do that. Some ray between a couple of other rays. Maybe it's an angle bisector, maybe it's not. We'll see about that. All these rays have the same endpoint at B. This must have been point B. And I'm going to show some ray BD between BA and BC. I'll call this one A, and there's ray BA. Call that one C, and there's ray BC. And here's ray BD between BA and BC. Let angle ABD, the measure of angle ABD, that's this one. That's 4x plus 4. And the measure of angle DBC, well, that's this one here, huh? That's 5x minus 4. And the full measure of the full angle ABC, the full angle, is 72 degrees. Like any other angle addition statement, I know that these two smaller angles are going to add up to the full angle. I'm going to write that equation. I can figure the value of x, and then I can find the measures of these angles. And if I can do all that, I could probably decide if BD is the bisector of angle ABC. So I would begin with 4x plus 4. That's the measure of angle ABD, plus the measure of angle DBC, which is 5x minus 4, would have to add up to the full angle, which is 72 degrees. Hope you wrote that equation before I did. Solve it before I do also. Pause this and solve that up. You would have got 4x and 5x is 9x. That positive 4 and that negative 4 add out to 0, so 9x equals 72. I'll divide both sides by 9 as I seek to isolate the variable. And x is going to equal whatever 72 divided by 9 is. That's got to be 8. So I know the value of x is 8. Now I've got to find the measures of those angles. Decide if BD is the bisector of angle ABC. I'll go with the measure of angle ABD. Angle ABD, since x is 8, 4 times 8 is 32, plus 4 would be 36 degrees. The measure of angle ABD ought to be 36 degrees. And then the measure of the, is it the full angle DBC? No, the other small angle, angle DBC. If x is truly 8, 5 times 8 is 40, minus 4 would be also 36. That's good. They do add up to 72. And since these two angles are equal in measure, I could even say angle ABD is congruent with angle DBC. So yes, BD bisects the angle. Bisects angle ABC. You'll do a better job than that. I appreciate you turning in the work at Canvas, and I'll get a look at it. The next thing we're going to do after this is probably going to take a quiz. So put your notes together and get ready for that. We'll talk more about that soon.